In this section, we're going to solve equations by factoring. We have a new type of equation. The way we will distinguish them from the type we learned before is the exponent. These have an exponent of 2, or possibly higher if it's easy to factor. We cannot just isolate the variable in these to solve. First, let's look back at a linear equation that we had before and remember how to solve it. This is an example of an equation we worked on before where the exponents are 1. This is called a linear equation or a first-degree equation. And to solve it, we isolate the variable. So let's go ahead and do that just to remember. So you distribute and simplify on the left-hand side. 5x plus 15 plus x. Combine your x terms to give 6x plus 15. On the right-hand side, you will also need to distribute your sign there, and that will give us 2 plus x. Then we have x on both sides. We get rid of an x term, so I will choose to get rid of this one. That will cancel to leave me 5x plus 15 equals 2. And then work on the side with your variable. So you're going to subtract the 15 from both sides to get 5x equals negative 13 and divide by 5. You will get a fraction, and that is okay. The x is isolated. That is our goal on this type of equation. For our new equations with an exponent of 2, they are called quadratic equations or second-degree equations. And degree tells you how many solutions are possible. So we can get up to 2 solutions when the exponent is 2. We will look at several techniques to solve these equations, the first of which is to factor and use the zero product law. So that's what we will do in this section. And we need a property to help us. This is called the zero product law. And this says if we have a product, A times B equal to 0, then either A equals 0 or B equals 0. Let's pick this apart just a little bit. One side must be 0. There is no choice. No other number could be here and use this property. The other side must be a product. The way you get a product, if you don't have one, is to factor. Right? Once you have those two conditions, you break your product apart and set each piece of the product equal to 0 and solve. Let's look at some problems. So when we first see this problem, what we want to notice is it is an equation. It has an equals. We don't necessarily want to jump and multiply it out, but we do want to know, is it the old kind to isolate the variable, or is it the new kind? If it was multiplied, it would be x squared. So it is the new kind. This one is actually set up exactly like your rule. It has a 0 on one side and it has a product. So it is ready to break apart to solve. So either the x minus 4 equals 0, or x plus 8 equals 0. And then notice now they're linear equations. So we're going to add the 4 to both sides. You just isolate now. Subtract the 8. And we get 2 solutions. We will often put these in solution set symbols just to keep them together since we have more than one. So negative 8 and 4. You normally put them from numerical order left to right. That's why I chose to put the negative 8 first. Next, we have an equation that would actually be x to the third if it was multiplied out. We can extend our A times B equals 0, our zero product law. It could be A times B times C equals 0, and it would still work. So that's what we're going to use here. We have the 0, we have the product. Here's our A, here's our B, here's our C, and here's our 0. We will just break it apart. So either x equals 0, x minus 3 equals 0, x plus 9 equals 0, and then we solve. The first one is actually solved. 0 is a number. That's a solution. If we put a 0 here, it's going to make the whole thing 0. Right? The next one, we will add the 3 to both sides, so x equals 3. And our third one, we will subtract the 9, so x equals negative 9. Because it would have been x to the third, we can get 3 solutions. So we will put them in solution set symbols. Our smallest is negative 9, 0, and 3. Our next problem is also an equation. We have the equals. Exponent of 2 tells us it is the new kind. It is not factored though. It has a 0, but it doesn't have the product. So this is where our factoring comes in. On the left-hand side, we factor. It is a trinomial. It is one of the nice ones with a 1 in the front. So we'll do our parentheses, do your signs. We'll have different signs. Split your x's. And we're multiplying to get 20, combining to get 1. How about 5 times 4? And we should do the 5 with the plus to make that work. You need to double check your factoring. I won't check on all of these, but if you factor wrong, you're going to solve wrong. So we have minus 4 plus 5 gives us plus 1x. Right. Now it's in the proper form. Here's your a, here's your b, here's your 0. So break it apart. Either x plus 5 equals 0 or x minus 4 equals 0. On the first one, we will subtract the 5, so x equals negative 5. The next one, we will add the 4, so x equals 4. So 2 solutions, negative 5 and 4. Our next one, also a quadratic equation. We have the 0, but we do not have a product, so we'll have to factor. This one's going to be a little bit more trouble to factor because we have a coefficient that is not 1 in the front. We can do what we call trial and error factoring. So do your parentheses, do your signs. This negative at the end says different signs. The front, to get 2, I'm going to use 2 and 1, and I'll still split the x's. And our choices at the end, we can do 1 and 6, 2 and 3, 3 and 2, or 6 and 1. We have to try until we get the right choice. And I'm going to go ahead and just put the right choice in so I don't take a lot of time with the factoring. Right, double check. Minus 12x plus 1x is minus 11x. So I have it factored correctly. We'll just get this out of the way. Now, this is equal to 0. We have our product. Here is our a, here is our b, and our 0. So either 2x plus 1 equals 0, or x minus 6 equals 0. And now it's linear equations, so you're going to isolate your variable. So subtract your 1. Write the steps if you need to. I don't always write these steps. 2x equals negative 1. Now you have one more step. You have to isolate that x. So divide by 2. X equals a negative 1/2. And for the other one, we just need to add the 6. So x equals 6. So negative 1/2 and 6. Our next problem is a quadratic equation. We have that exponent of 2. It does not have the 0. So our first step is get a 0. So you're going to need to subtract that 8x. So we'll have x squared minus 8x equals 0. And then we need to factor on the left-hand side to get a product. You're going to need to do a GCF here. You couldn't do squares or anything like that because of this x. So, but you have x in both terms, so do a GCF. So x times x minus 8 equals 0. Then we're set. Here's our a, here's our b. So either x equals 0 or x minus 8 equals 0. The first one's already solved. 0 is a number. The second one, add your 8 to both sides. So we have 0 and 8. Our next problem, also a quadratic equation. There's your equals, exponent of 2. It is not in the proper form, so we want to get a 0. For this one, Because we would like to always keep a positive square term, we will get rid of the 34x and the 6. We'll move them to the other side. So we're going to subtract 34x, and we're going to subtract a 6. So 12x squared minus 34x minus 6 will equal our 0. Because we wanted a positive square term. Now we have to try to factor. We do have a GCF in this problem. We have a 2, so we'll take that out, and that will leave us 6x squared minus 17x minus 3. And then we will have to try to factor. This will be a trial and error problem with different signs. Again, I'm just going to give you the correct factoring so that I don't spend too much time on that. 6 plus 1 and x minus 3. Double check. There's our minus 18x plus 1x equals minus 17x. Now you're set to break it apart. This is our A, this is our B, this is our C, equals 0. So we have 0 equals 2. We'll leave that for right now. 0 equals 6x plus 1. And we have 0 equals x minus 3. For the first one, you don't get a solution out of this piece because there is no variable. So anytime if there is just a constant outside, you can throw it out. You're not going to get a solution from that. And we could not because it was x squared. So we could not get 3 solutions. So this one gave us a false statement. We're not getting any answer out of it. Just solve the other 2. So we're going to subtract 1. Divide by 6, so x equals negative 1/6, and this one add your 3. So 3 equals x. So 2 answers, negative 1/6 and 3. For our next problem, it would be a quadratic equation if it's multiplied. We have a product, but we don't have the 0. You have to have the 0. So we need to subtract the 2 from both sides. And when we do, it's going to mess up the product on this side. So we actually have to multiply before we can work this one out. So we get 5x squared plus 9x minus 2 equals 0. You have your 0. Factor on the left. This has different signs. You're going to need 5 and 1. And the correct factoring is going to be 5x minus 1 and x plus 2. So I'm actually going to have to switch my signs to make this work. So you go through the normal steps there to factor, and then we can solve. So either 5x minus 1 equals 0 or x plus 2 equals 0. On our first one, add your 1 to both sides. Divide by 5. So x equals 1/5. Our second one, subtract your 2. X equals negative 2. So 2 solutions, negative 2 and 1/5. Next problem is a quadratic equation with fractions. So we want to clear the fractions out. Remember to find your common denominator. It looks like a 20. Multiply every term by 20. You're doing that on the top so that all your denominators will cancel. So 2 will go into 20 10 times. So we have 10x squared. And next, the 20s will cancel. So we will have plus x. Bring your equals down. And on the other side, the 10 will go into 22 times 2 times 1 is 2. All right, now we will have to get a 0 on one side. So we'll subtract the 2. 10x squared plus x minus 2 equals 0. And then you will factor. This is a trial and error factoring. I'm just going to give you the proper factoring. It is 5x minus 2 and 2x plus 1 equals 0. So you break it apart. If our first one equals 0, we'll add the 2 and divide by 5. So x equals 2/5. For the second one, you will subtract your 1, divide by 2. So x equals a negative 1/2. We can put those in solution set symbols. So negative 1/2 and 2/5. Our next equation, it actually has a 3 for an exponent. If we can factor it, then we can get it to solve this way. So first, let's go ahead and get a 0. So we'll move those terms off the right-hand side. So minus 9y minus 9 will give us a 0. For terms, we try grouping on those for factoring. So in the first group, we can take out a y squared, and that leaves y plus 1. In the second group, because it starts off with a negative, choose a negative GCF. So we will take a negative 9, and be careful here, it leaves a y plus 1. You already pulled that negative out. Right? What you hope with grouping is that you get a common binomial, which we did. So we can pull the y plus 1 out and pick up our other pieces, y squared minus 9. What you have to watch out for on this problem is that y squared minus 9 will continue to factor. Anything still to the second power, you have to see if it will factor more. It is now a difference of squares. Right, and so we have 3 things here to solve. We will be able to get 3 solutions. That's okay because it was y cubed. So just set each one equal to 0. So y plus 1 equals 0, y plus 3 equals 0, y minus 3 equals 0. So we get y equals negative 1, y equals negative 3, y equals positive 3. So we can put our solution set symbols. So a negative 3, negative 1, and 3. We'll look at one more problem. This one is going to have to be multiplied out before we can do anything with it. It would be x squared, though. So we'll distribute on the left, gives us 3x squared plus 5x. Bring your equals down. We'll distribute on the right, gives us x squared plus 2x plus 14. Right, you have x squared on both sides. You need to get a 0 on one side, so you need to get rid of all these terms off the right-hand side so that you'll keep a positive square term. So we'll subtract 1x squared. 3 minus 1 will give us 2x squared. We'll subtract the 2x. 5x minus 2x will give us 3x. And we'll subtract a 14 to give us 0. Then we'll factor on the left. I'm just going to go ahead and give you the factoring. It will be a trial and error factoring. So you take the time to do that. 2x plus 7, x minus 2 equals 0. Now you can solve. So to set your 2x plus 7 equal to 0, x minus 2 equals 0. On the first one, subtract your 7. Divide by 2. X equals negative 7/2. The second one, add your 2. So 2 solutions, negative 7/2 and 2. And this was just an example when you have x squared on both sides. You still need to get the 0, so get rid of one of those. Keep a positive coefficient on your square term.